So now we're going to talk a little bit about the ACI topology, because a lot of us are used to our traditional networking topologies, and within a lot of data centers that was historically those three-tiered architectures where we'd have the access layer, we'd have the distribution layer, or what we refer to as the aggregation layer, and then the core. And what we typically did is we try to delve out, where do we stop our layer 2, where do we do layer 3, and a lot of that was due in part to the fact that we had to run spanning tree within our layer 2 domains as our basic loop prevention mechanism, right? Spanning tree was our control plane protocol for layer 2. So this changes a little bit with ACI in that we're using more of like a CLOS or CLOS architecture. And let's dive in. Let me get my head out of the way here and we can take a look at this. So what we have and what you're kind of looking at here would be an example of like an ACI fabric. So these switches here at the top of this architecture are going to be what we refer to as our spine switches, and these guys down here are going to be what we refer to as our leaf nodes. And this is kind of representative of what we saw within Fabric Path as well, or what's now known as DFA. We had a spine leaf architecture with that, and there's a lot of the same little nuances as well between Fabric Path and ACI. ACI, of course, uses VXLAN, but the kind of smushed down topology rather than having that gigantic three-tiered architecture. Remember with the three-tier, this would be like our ag layer, this would be our leaf layer, or sorry, our access layer. Let me see if I can back that thing up. Let's go back here. This would be our access layer, and then this would be our core. So it changes a little bit, right, with ACI, because now we don't have those three tiers. We're really just dealing with the two. So let's get rid of these. So again, these are going to be our spines and our leaves. So what you'll see with ACI is that typically all of our layer 2 is going to stop kind of right here with these leaves. So everything layer 2 will be down here. Let's draw in some happy little blue links. So like these would all be layer 2 connections. Let's forget that these are apex for a minute. Just pretend that these are our normal hosts. So maybe this is host 1, this is host 2, and this is host 3. We could even come down here and we could attach non-ACI switches to these guys. And this would kind of be where our layer 2 stops, because everything up here within the fabric between our spines and our leaves, all of this is going to be layer 3 routed. Okay? And what we are going to find that we use within the ACI fabric for our underlay routing, which is what's going to be routing all these links, is actually IS to IS, or intermediate system to intermediate system. So again, some similarities there with Fabric Path in regards to the control plane protocol that we're using within there. And it was chosen again for a lot of reasons. No IP dependency, of course, the ability to do inherent equal cost multipathing, the ability to carry other type length values. So this ACI fabric, this spine leaf topology, what we're going to find is right now, with the current versions, at least what I've deployed, these are all going to be 40 gigabit per second connections, while down here we'll still have the ability to do our 1 and 10 gig connections down to the end host. Okay, so these are all currently 40 gig BiDi optics. So again, you can reuse your existing cabling plants for a lot of those connections. So 40 gig, again, a lot of the benefits that we're going to get out of this is that we can do equal cost multipathing. We're going to talk a little bit more about that here in just a little while. And what you'll find from a device capability or a device model perspective is typically these spine switches that you guys see up here, these are going to be our 9500 series spine switches, so basically our modular switches within the 9K lineup, though we do have the ability to use, say, this 9336 as a spine switch as well, which is one of the 9300 fixed models. And I'm going to show you guys that within the CCIE Data Center version 2 blueprint, let me get my cursor back here. Come on, cursor. Whoa. Let's click plus. Within this new blueprint for the lab exam, again version 2, you can see that we're going to have an actual 9336 spine switch. And again, that's because it has that application spine engine ASIC within it. And then these are going to be our leaf switches. Okay, so we're going to be using the 9372s as our ACI leaves. So those are the two that I want you to get real familiar with. There's also, if your company's interested, there is what they refer to as an ACI lab bundle. And the ACI lab bundle is actually I think you can get a 9336 spine, so we'd have our 9336 spine switch, and then we'll also have these 9372 leaf switches. So we do have this lab bundle that has a single spine and 2 leaves, so we'd be connected something like that. And then we're also going to get one APIC, which we haven't talked about yet. It's going to be the controller where we do basically all the configuration, and that APIC can connect up to a single or dual leaf switches. So the ACI lab bundle would give you sort of this ACI topology that you could play around with, and that's actually what I do. A lot of my work on is developing these lab bundles and pushing them out to clients so that they can kind of play with ACI. So again, this is what's going to be on the lab exam version 2 blueprint. I believe at cost, this is around $100,000 for this ACI lab bundle. And don't quote me on that. That was the last time I looked. A lot of Cisco partners can get this NFR'd, so you can get quite a chunk taken off of that, but you're still looking at approximately $20,000 to get an ACI lab bundle NFR'd in. So it is an option for a lot of people, though. There's also the ACI simulator that you can play with, but that's still going to run you about $20K, and you can't really pass traffic through anything with the ACI sim. So going back over here, go back to this. Those are typically going to be your spine switches. So again, the 9336 or the 9500 more modular switches. And the 9500s can have 40 gig, 100 gig line cards in them that give you the capability to either be a spine or a leaf or basically just like a top of rack. We're also going to have the 9300 typically fixed switches that are going to be acting as our leaves. And these are typically going to be what we refer to as the TOR, or top of rack switch. So these are going to be the guys that we actually hang clients off of. Okay, so when we have servers, when we have other switches, we're going to be connecting those guys to those leaf nodes. Now, there are a couple caveats when you start constructing these topologies. For instance, you can never cable a leaf to a leaf. So if I tried to run a cable between these two guys, that would not be allowed. We also could not run a cable between 2 spines. Again, this is something that is just not allowed at this point in time. And the system will pick up on this. Basically, within the fabric, we're going to see that we're always running the Link Layer Discovery Protocol, or LLDP. And leveraging this, they also have a protocol called MCP, or the Miscabling Protocol. And basically, MCP is going to pick up, if you cable up 2 leaf switches together, or 2 spine switches together, or if you try to hook a host up to a spine switch, for instance. You can't do that either. So there's quite a few nuances, but again, the combination of LLDP and the Miscabling Protocol are going to pick that up, and they're basically going to bring down those links. Okay, so typically your clean slate, how you're always going to see this cabled is you're going to have a spine or multiple spine switches, and these guys are going to be connected to every ACI leaf switch. So basically, every leaf has a connection to every spine. Again, no leaf to leaf, no spine to spine communications. Okay. Now, we do this because we're able to leverage equal cost multipathing. So say, again, let's forget that these are drawn in as APICs right now. Just pretend that we have host 1, we have host 2, and we have host 3. We have the capability, if you think that maybe host 1 wants to communicate to host 3, when we go to send those frames, as they come up the wire here to that leaf switch, he's actually got 3 equal cost paths. He could go this way, or this way in order to reach host 3, right? Because again, if we stuck some just fake costs on here, if this was each link was a cost of 10, he'd have a cost of 10 here, 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 a cost of 10 here. So any of those are applicable equal cost paths, right? Because they ultimately have the same cost in this scenario of 20. So the ability to do ECMP, and typically what you're going to see is that, much like with Fabric Path or even port channels, any given flow is always going to follow the same traditional path. Okay, there are some caveats to that where we can break stuff apart, but we're not going to get into that at this point in time. Just know that we do leverage equal cost multipathing, and that's one of the inherent benefits of using these clause type topologies. Okay. Let me erase my board here. So the ACI topology in a nutshell, even though like the physical ACI topology view might look something like this, logically to anything outside of the fabric, we really look more like just a single switch. And if you think about how this is kind of constructed, right, imagine a box around this topology. These leafs, even though they have many ports, imagine them for a second like they were just a single port. So this would be a front panel port, this would be a front panel port, this would be a front panel port, this would be a front panel port. So from a cabling perspective, that holds true, right? Because we're always going to connect, our servers or our switches or our hosts into our leaf switches. These spines are really like, I don't want to say they're the brains, but they're really like the old Ethernet out-of-band channel, right? This is basically the internal bandwidth of this logical switch that we're building, because we're going through those guys, right? We're going through these guys, we're going through this guy. So it's really like just the internal fabric for this switch. That's how we scale our bandwidth out within ACI is, how do we add more lanes to this topology? And really that's just coming in here and adding another spine switch, right? And then we cable that guy up to all the leaves. If we need more, we add another spine switch. We cable that guy up to all the leaves. And now, basically, we're giving ourselves the ability to almost seamlessly scale this fabric. Okay, because again, the underlay routing, which we're going to learn as IS to IS, is just going to pick up these new adjacencies, add them to the equal cost multipathing tables, and we get to move forward with life. Now, again, part of VXLAN, if you haven't taken the VXLAN course or looked at any of the VXLAN videos that are out there, there's two real components to VXLAN. VXLAN is composed of an underlay, and then the part we deal a little bit more with, which is the overlay. Okay, so ACI, and I have APIC here, this should read ACI. ACI uses VXLAN. And we're not using the exact formatted header as just traditional VXLAN. There are some variations to the VXLAN header within the implementation of ACI, but we do leverage VXLAN within ACI. Now for the underlay, what we're going to find is that in here within this cloud, again, we're using intermediate system to intermediate system to basically form those adjacencies and to advertise what we're going to learn are our VTEP or our VXLAN tunnel endpoint addresses between all of the different switches. Now, if you've dealt with IS to IS a lot in the past, you know there's two types of adjacencies. You have L1 adjacencies, and then you have your L1 to L2 adjacencies. We are strictly dealing with L1 adjacencies. And again, this is one of the similarities interface to fabric paths, so we have no L1 to L2 adjacencies. These are all going to be internal L1 adjacencies between these spine switches and these leaf switches. Okay, so what we're going to do for the underlay is we're going to leverage IS to IS to form these adjacencies, and these are going to be on what we call IP unnumbered interfaces. And as we start to build out the fabric, we're going to learn that each one of these switches is going to get a loopback 0. Okay, and this is basically a unique IP address to those particular switches. Okay, and we're going to learn what this is all about, but basically we're going to see that we leverage these as our VTEP addresses as well. So this loopback 0 is basically going to be used because all of these other physical interfaces are just going to say IP unnumbered loopback 0. Okay, so we're going to form adjacencies using those IP unnumbered connections, and again, that is how basically ACI advertises these VTEP or these VXLAN tunnel endpoint addresses between all of these different nodes. So this guy, so if this is VTEP 1 and this guy is VTEP 2, the underlay is basically going to announce that, hey, you go through me, or you go through me, or you go through me to reach VTEP 2. Okay. Likewise, this guy will have the ability to go up through this guy. He'd have the ability to go up through this guy, or he'd have the ability to go up through this guy if he wanted to reach VTIP 1. So again, that is basically what the underlay is there for. It's there to advertise those VXLAN tunnel endpoint addresses between all of the different nodes within the fabric. Okay, and this is how we're going to form basically our VXLAN tunnels on the overlay side. We're also going to see that this generates these F-tag trees, and again, if you guys have dealt a lot with Fabric Path in the past, these F-tag trees are basically what we used to refer to as our multi-destination trees. We'll find with ACI that we're going to build 16 of these trees no matter what. So if we have 16 divided by 3, this is going to be the responsibility basically of these spine switches. So if we had 4 spines, so if I added another spine switch to this equation, this 16 would be distributed pretty equally. Like this guy may be 0 through 3, this guy may be 4, 5, 6, and 7, this guy may be 8 through 11, and this guy would be 12 through 15. Okay, so each one of those would have basically an equal distribution of those F-tag trees. Of course, if you have an odd number, some are going to have more than others. But again, this is how we route a lot of that multi-destination traffic within the ACI fabric. Now, we'll also find that we have this thing called the APIC. And the APIC is actually the ACI controller. Okay, this is where we're going to see that we do all of our moves, adds, changes, and deletes. Now, one of the most important parts about the APIC is even though we're doing a lot of our configuration on these APICs, so again, this guy, or this guy, the APIC is not in the control or data plane. Okay, and that says data plan, but it should be data plane of the fabric, meaning it's not like imagine that we have a host over here. And imagine that this host sends some data in, right? And we kind of explained in the introduction video that some sort of policy is going to be applied to that guy as he enters the fabric, right? Those leaf switches, these guys are basically our enforcement point. So what this is saying when it says it's not the control plane, it means that basically as this packet arrives up here and we know we need to enforce some policy, this guy is not going to go out here and say, you know, query this guy like, oh, what do I do? Okay, that would be kind of a control plane function. We don't do that. Okay, we do not do that. So it is not in the control plane. Basically, we'll come into this guy, so every, Tom, Dick, and Sally, we'll come into the APIC and do the configuration on that. But once that configuration is put in here and the APIC knows that a certain policy needs to be pushed out to this guy, we are going to go ahead and send that policy information to those leaf nodes that need it. All right. That way, as these frames arrive in, we can go ahead and apply that policy and forward that data on. Make sense? And when we say it's not in the data plane, let me get a clean slate here. when we say this guy's not in the data plane, again, if we have a host here that wants to send data into the fabric, imagine he sends a frame in, we're never going to send that through the APIC and then back out to the fabric. Okay, that'll never happen. So it's not in the control plane and it's not in the data plane. That being said, could you lose your APIC and have the fabric still functioning if you already had it configured? Yeah, absolutely. You know, in that regard, it's a lot like the VSM for the 1000V, because the VSM's not really in the control plane or the data plane either, right? And you can lose the VSM, but when you lose the VSM, it's much like when you lose the APIC, you basically don't have the ability to do any of this stuff anymore. You can't do any moves, adds, changes, or deletes. Basically, you have no visibility into the fabric at that point. And that, guys and gals, is why Cisco actually requires that you have to have 3 or more APICs for redundancy and for quorum. Okay, so if you're going into a production-based environment, it will be required that you have at least 3 APICs within your topology. Now you'll see, again, I talked about the lab bundle a little while ago. The lab bundle only had a single APIC. So can you configure and get an ACI Fabric up and running with just a single APIC? Absolutely. Absolutely. But you are forever going to have this warning basically at the top saying, I don't know the exact verbiage, but it's something to the extent like your fabric only has 1 APIC. Do not go to production. And it's always at the top, and it's always this big red banner at the very top of your web browser. So they definitely do let you know that you're running, you know, less than optimally from an APIC standpoint. Now, what we'll find is that typically when we go into these guys, we're going to want to cable these guys, you know, dual homed off of our leaf switches. These are going to be 10 gig connections from the APIC controller. And I think the latest release for like a medium-sized APIC, you're going to get that C220 M4 as your APIC controller, and that is a pre-built appliance. Again, Cisco preloads the C220 M4 with the APIC software in it, and again, that runs a variant of CentOS. So again, you can't just take a normal C-Series server and load the APIC software on there. It doesn't work like that. These are going to be tried and true, hardened, pre-installed appliances coming straight from Cisco. And again, they're going to have a VIC card in them that you use to connect to your ACI switches. So you can single home these guys. Cisco does recommend to dual home where possible. Again, they're really there, and you have multiple APICs for redundancy purposes, because what's going to happen is as you go in and you perform configuration on these guys, so as we come in here and we place some config on there, what's going to happen is that data is going to be what they call sharded, and I think I've got it in here somewhere. Yeah, it's going to be sharded across those nodes, meaning as you configure something, we're going to have replicas out there. So like this guy's going to get a shard, this guy's going to get a shard, this guy's going to get a shard. You go in and do other configs, this guy's going to get a shard, this guy's going to get a shard, this guy's going to get a shard. So you have basically your shards, and then your shards have replicas. So with 3 different APICs in here, basically everyone's going to have a copy of the data. Okay, the APIC is, again, the place that we're going to go to for most of our config, especially throughout this course. All of our configuration, we're not going to be doing any scripting, we're not going to be doing any of that. We're going to be going directly to the APIC IP address within a web browser. And I'll tell you guys, again, from an experience standpoint, I've had luck running it on Internet Explorer, I've had luck running it on Firefox, and I've had some luck running it with Chrome, but I've had a lot of problems running it in Safari. So I'm a Mac guy, and I've tried browsing a couple hundred times using Safari, and it's been nothing but trouble. Internet Explorer's given me trouble quite a few times as well. So really my go-tos for accessing the APIC now are either Firefox or Chrome. And again, it may be different for you guys, but I'm just telling you from my experience, that's what's happened to me. So typically the APIC is going to be accessed via one of these two web browsers from my standpoint, and basically just browsing to the IP address of one of these guys. Okay. Now, we'll also talk a little bit, and this is one of the demos that's coming up, is going to be the Fabric discovery process. So as you basically come in and cable up your ACI Fabric. So you may cable it up and it may look, exactly like this. We're actually going to be, as the administrators, going into one of these APIC controllers. So let's say that we choose this guy to console into. So we could hook, a KVM up to this guy. You could, as this server boots, you could hit, F8 and go through the SIMC configuration utility, assign it an IP address, and you could access the SIMC at that point, and thus the KVM from within the SIMC. And I'll tell you again, just per me, this is usually the method that I use. I'll usually hook up, to it via keyboard, video, and mouse to the C-Series server itself initially, and I'll immediately set up the SIMC. And that again is just something that I do normally. But what's going to happen is you're going to get kind of this text-based setup utility, and it's going to ask you for some names, how many APIC controllers you have, what multicast range you want to use, what the out-of-band management IP address is going to be for this specific APIC controller. And then you're going to have, after you do that initial configuration, you're going to have one of the two NICs on this guy is basically going to be an active NIC, and the other is going to be standby. So let's say this one's our standby. So initially we're going to see, this leaf first. Well, what happens as you go through that setup utility is you actually build basically this big address pool. And this address pool is what's going to be used for basically our VTIP addressing within the Fabric. So I think the default is actually going to be 10.0.0.0/16. You could change that if you want, but these addresses are never really going to be reachable outside of the Fabric. Okay. We're also going to set up a VLAN, and typically I think I'm going to use VLAN 4. This VLAN 4 is going to be what we refer to as our infra or infrastructure VLAN, and I think I have it down here, put infrastructure VRF. But this is going to be the VLAN that we use to basically discover and send out IP addressing to the different Fabric members. Okay, so basically the spine and leaf switches. So what's going to happen as we go through this Fabric discovery process is, remember, within the Fabric, LLDP is explicitly enabled. We can't turn it off. So I know the arrow here is kind of just showing, LLDP going one way, but really LLDP is kind of flowing in both directions. So what happens, once we get everything cabled up and once we do the initial configuration on the primary APIC, is LLDP starts to kind of do its thing. So, this leaf switch will be sending out LLDP frames, and using some ACI, what I call ACI specific type length values here, specifically in OUI, we're going to be able to see that there is an ACI component at the other end. And what happens once that leaf switch sees that APIC controller, it's going to go ahead and get its loopback IP address handed out from this pool that we created during the initial config setup. And again, this is all going to be done within that infrastructure VRF. Okay, and again, that's going to be riding on that infrastructure VLAN. So this guy is going to pull a VTIP or a loopback 0 address, and then we're going to find that the Fabric basically automatically converges after this. So what we as the administrator have to do during the Fabric set up is we're going to give this guy a name. So maybe we're going to say you're going to be leaf 1. We're going to give him an ID. The IDs are going to have to start. The lower bound is 101. So we're going to have to basically go from 101 up. But once we assign this information to this leaf switch, he's going to go ahead and pull his DHCP address, and then basically the fabric just starts converging. So we'll see again through LODP that we'll discover one of these spine switches next. We might come in and say you're going to be, spine 1, maybe you're going to be ID 201, and then the fabric just kind of continues to fold out. Like he'll pull an IP address at that point. LLDP will find all the other switches. We'll give them a name and an ID as well. And basically at that point, our fabric will be discovered. Okay, our fabric will be discovered. Now, using what we call an appliance vector, and that's just a term that you'll see, we'll have this appliance vector. When we did the initial, or when we go through the initial setup, it asks us, how many APICs are you going to have? So if we put in, hey, we're going to have 3 APICs, I'm going to be APIC 1. Once the fabric discovery process gets to these other APIC controllers, and they're within the same appliance vector, they're going to go ahead and join the cluster. Okay, so now all of these APICs are basically going to be clustered together, and that's kind of our end result. So this is the fabric discovery process. The next thing that we'll see, again, I'm going to go through a demo. That'll be the following video to this. Our ACI bootstrapping is going to look exactly like this. Basically, we have a spine out here. We've got 2 leaves, so we're going to have leaf 1 and leaf 2. I also just have a single APIC. He is dual home to both of these leaf switches. I'm not sure which one's active and which one's standby. We very well could have, the active link could be over here to leaf 2, and then the standby link could be over to leaf 1. And if that is the case, basically the first switch that we're going to discover is leaf 2, and then we'll discover this spine, and then we'll discover this leaf. So we'll be able to verify using serial numbers which one we're hitting first. Okay, we'll be able to verify pretty cleanly which one we're actually going to hit first. So again, this is all going to be done through the use of link layer discovery protocol and basically a DHCP-ish process. We'll also be able to go in or console in to each of these leaves, and we should be able to see after this the loopback 0 and the IP address that's been assigned to each of those loopback zeros being pulled from the pool that we have actually configured during the bootstrapping process on the APIC. Okay. Now, from a much more grandiose scale, our entire topology for all of our labs and demonstrations is going to look a little bit like this. Again, we're going to have our spine switch. We're going to have an out-of-band management pool that we're going to be using, leaf 2, leaf 1, and then basically I've got a couple fabric interconnects hooked up. I have switch 2.2 and switch 2.1, which are basically just 2 external Nexus switches that we'll be doing layer 2 and layer 3 configurations towards. We of course have our APIC up here in the middle, and then I have an ESXi host. So we've got a couple, actually I think 3 VMs. I've got a web VM, an app VM, and a database VM, all riding on this ESXi host. So we'll do some integration with that as well. So this is kind of what the grand scheme of all our demos are going to look like throughout the remainder of this course. So in the next video, what we'll be doing is we'll actually be demonstrating the bootstrapping of the APIC controller. So we'll go ahead and do that bootstrap. We'll go through the initial setup on the console, and then we will go we kind of get our first glimpse into the APIC GUI, and we will go through the fabric discovery process. Because again, there's 2 real configuration components to ACI, as you guys are going to see it. There's going to be like the physical fabric configuration, and then what we call the tenant configuration. So really, we're going to mainly, for the first couple demos and the first couple exercises, we're really going to be doing mainly physical fabric config.